Welcome back to the 2025 APAICS Technology Summit. I'm Tanya Layden, Vice President of Development and External Affairs. Our next panel is Wi-Fi Forward, Spectrum Policy, Innovation, and Equity in America's Digital Future. As demand from next-generation technologies accelerates, forward-looking spectrum policy is essential to prevent congestion that could impact tens of millions of Americans and slow economic growth. This panel will discuss how protecting and expanding unlicensed spectrum can fuel U.S. competitiveness, generate billions in economic value, create millions of jobs, and ensure all communities, including the AA and HPI populations, have access to opportunities of a connected future. It is now my pleasure to introduce KPAC Executive Member Senator Andy Kim, who represents the state of New Jersey. Senator Kim serves on several influential committees, including the Committee on Banking, Housing, and Urban Affairs, the Committee on Commerce, Science, and Transportation, the Committee on Homeland Security and Government Affairs, and the Committee on Health, Education, Labor, and Pensions. Please welcome Senator Kim to the summit.
Hi, everyone. I'm Senator Andy Kim, and I just want to say thank you for letting me be able to say a few words that you gather for the APAICS Technology Summit. There's so much happening right now that is both exciting but also scary. We are at a time of witnessing some of the steepest curves of an acceleration of innovation that we've seen in modern history, certainly in my lifetime. It's a time of extraordinary accomplishment. And that's exciting, but it's also going to have a huge impact in reshaping our economy, the workforce, and shaping, who are able to benefit from this technology and what comes next. And that's why I think it's so important that you're gathering together to talk through this, to understand the implications and impact of what's happening. This topic here about Wi-Fi Forward gets to the heart of this, which is about who has access to this kind of technology. We see how Wi-Fi and just digital access writ large, it's not equal across our country, that there are stark divisions that are creating this divide and is going to create a divide of economic opportunity and prosperity as well. That's something we try to get ahead of, to try to make sure we're addressing this in a means that can hopefully lift everybody up, not just a few, not just those that have capital, those that have the education from the outset. Should be something that is broad. That's what we're going to work for. But we don't have all the answers, and we need you and others to think through this and to help us understand how we put ourselves on a better path, to use technology innovation for the good of all of us to be able to benefit from. So I appreciate your commitment to that mission, and I'm going to look forward to working alongside you to get that done.
Our moderator for this panel is Mary L. Brown. Mary is the Executive Director of Wi-Fi Forward, an organization of entities seeking to promote and advance public policies that enable Wi-Fi technologies. Mary is a spectrum and technology policy expert with decades of experience in Wi-Fi, as well as other wireless technologies. Please welcome Mary and our panelists to the summit.
Hi, everybody. Welcome to Wi-Fi Forward, Spectrum Policy, Innovation, and Equity in America's Digital Future panel. My name is Mary Brown. I serve as Executive Director of an organization called Wi-Fi Forward, which focuses on how public policy can support and advance Wi-Fi. But I've been around spectrum issues for a long time, and I'm delighted today to be moderating this panel with two true experts in wireless and wireless technology here today, Monisha Ghosh and Stuart Strickland. And before I introduce them more fully to you, let me just frame what the panel is about so that you understand where we're headed in this next 45 minutes. First of all, radio spectrum is more important than ever before. Wi-Fi and other unlicensed technologies like ultra-wideband that we use for the key fobs for our cars citizens band broadband radio systems with CBRS, which we're going to talk a lot about, 5G, private 5G, and a host of federal uses for spectrum, like satellite for weather forecasting and many, many other uses, are really crowding the spectrum. There's a lot of competition for radio spectrum in America. It's true all over the world, but it's particularly true here, where we love to use our radio spectrum. We recently had a major piece of legislation move through Congress as part of the One Big Beautiful Bill Act. There was a spectrum title in that bill. And that set an enormous amount of spectrum in motion, 800 megahertz, which for those of us who are in the radio world know that is an almost unprecedented amount of spectrum, is moving from the federal side of federal user side over to the FCC to be used for commercial spectrum, and there's some FCC spectrum that's going to be repurposed for cellular. So this is a big change to fuel future 5G networks, and that's of course prompting a lot of discussions, a lot of debates around spectrum use in our country and what's the best purpose for these spectrum bands. But a lot of spectrum will be changing hands over the next few years. Meanwhile, at a technology level, things are changing very rapidly. So we've had, as a result of the FCC's action in 2020, opening up the 6 gigahertz band for Wi-Fi, we've had a whole new generation of Wi-Fi launched into the marketplace, known as Wi-Fi 7, with more innovation on the drawing boards still to come. We've had citizens broadband radio services maturing and growing, which is a very innovative service that uses a database to tell operators what spectrum is safe for them to use without interfering with others. This is a wholly new approach to how we utilize spectrum, and the U.S. is unique in deploying it. So very interesting topics. The big trends in spectrum continue to be that most of our use is indoors. Most of our use, therefore, is Wi-Fi as we stream video every night to our television sets. We are seeing increased enterprise dependency on radio systems as they integrate wireless into their business operations. So not just internet access in the office, but actually in how they're actually producing things and services. That continues apace. And the ability to do it yourself, CBRS and Wi-Fi being examples of systems where there's a very low barrier to entry. So people don't necessarily have to go to a carrier to buy wireless services. They can do it themselves. So society is going to need all kinds of spectrum in the future. It's going to need these outdoor mobile networks that we go to our carriers and subscribe to. It's going to need the kind of shared use spectrum that CBRS represents, and a lot of unlicensed spectrum too, not to mention the federal uses that I talked about earlier. So today, our panel is going to talk about how do we meet those challenges and what's best for us as a society. How do we look at this time of very unprecedented change in spectrum availability and technology to meet our future needs as a society? So let me first introduce to you Dr. Monisha Ghosh of Notre Dame University, Department of Electrical Engineering. She has deep expertise in wireless technologies. She's an IEEE fellow. She's the former chief technology officer at the FCC and a veteran of the National Science Foundation, where she managed wireless networking research. And I know she has testified multiple times on the Hill, as I have testified alongside her in some of these hearings. So she is our first panelist, and our second panelist is a longtime friend of mine, Stuart Strickland from HPE, Hewlett Packard Enterprise. Stuart leads the wireless CTO function at HPE. And let me just list a few of his organization's responsibilities for those of you who don't know what a chief technology officer might do. His group has to participate in all these global standards bodies around wireless, of which there are many, constantly meeting around the world, advocate for favorable regulatory policies from places like the FCC, but agencies like the FCC in other countries. He runs a wireless lab generating performance data and developing algorithms for future commercial technologies. Incubates innovative product initiatives such as Aruba AirPass, which is a Wi-Fi neutral host product. We're going to talk about what neutral host means. Open Locate, which is indoor universal location, and wireless artificial intelligence. So I want to get into a little bit of that. He's also involved in HPE's development of enterprise private 5G, and in his spare time oversees customer engagements for HPE with pilots and proofs of concept, etc. So a couple of true heavyweights. Welcome to the panel. I'm so excited to have both of you here.
Thank you,
Let me start off, Stuart, with you. And what I'm going to do is I'm going to ask you a couple questions. I'm going to go over to Monisha and ask her a couple questions, and we're going to bounce back and forth. And feel free to jump in on any topic, because you guys are deep in all of these areas that I'm going to ask about. So I'm interested in your comments and thoughts, or maybe you have questions for each other or for me. So first, Stuart, HPE has been talking a lot about artificial intelligence in wireless networks. How is AI changing wireless connectivity, and what are the trends that we should expect in the future?
Right. So that's a big topic. And I think that it's probably most useful to think about it in terms of at a couple of levels, starting with the way that people are going to interact with it all the time. And I think there's a lot of continuity there. And although it's complicated under the hood, it's going to be very familiar. So most of the higher level artificial intelligence work that we do has to do with making it easier to configure networks, to interact with network as an administrator or manager, the way you would talk to a friend, rather than having to read the manual, simply asking it telling it what you want to accomplish, and then under the hood, artificial intelligence reads the manual for you, relies upon a lot of experience that we've had in networks similar to yours to not only make recommendations but act upon those recommendations. So that's probably the way that most of our customers encounter artificial intelligence. That's by no means an exhaustive description of what people understand when they talk about it. One of the things that makes that possible, and that leads us to a lot of other, in my view, more interesting aspects, because there's more math involved in them, is that we have access to a lot of very varied experiences across different kinds of networks, some of them heavily loaded, some of them complicated, some of them covering wide areas, some of them very dense, like, say, a stadium, some of them in factories, somewhere there are hard real-time constraints. And the behavior of those networks is something about which data is being constantly collected. People change those networks. Good things happen. Awkward things happen. We learn from that experience, or the AI systems learn from that experience, and make recommendations or take actions on their own. And then even deeper, we have a lot of problems that we don't really know the solutions to in terms of technology. Sort of, you mentioned location, we have a lot of different sensors like GPS receivers and measurements between access points. And we have algorithms that we've developed to try to turn those into useful information, but we don't always know. There's stuff hidden there that the human being can't always immediately see. And so collecting all that data and using things like neural networks and machine learning to understand and detect patterns, and then to turn that pattern into something that makes sense to a human being or makes a difference in a network. Those are the sort of things that we're doing in artificial intelligence.
So you're making networks much easier, really, for IT departments to administer, right? It's a lot easier when you can use just a native language and find out about how to maintain a network and all of that. Why is location so important? Could you give us just 30 seconds on that?
Oh, 30 seconds on the last 30 years of my career. That's
30 years of your career in 30 seconds.
So the simplest way for me to say this is that there's some kind of information that is available all the time and we take for granted. And a really good example of that is time, real-time clocks. We always know, our devices always know what time it is, and if they use that to timestamp things, to synchronize things, to record records, to be able to go back and look for things, to order them. We have not historically had that same kind of reference point for where you are in the world. There's been a lot of breakthroughs in that. And a lot of that came as a result of 911 regulations that led to GPS receivers being in phones. But there are enormous gaps in knowledge about where you are as you move through space. And we want to close those gaps so that you can take that for granted as much as you take time of day. There are a lot of challenges in that. We don't have easy access to the GPS satellites inside of most of the buildings that we work in. But there are also solutions. And so we combine lots of different kinds of measurements and provide that. Our job, in my view, as infrastructure, is to create reference points so that client devices can orient themselves around them. So we have the advantage of having, although we're almost always deep indoors, fixed devices that stay on the ceiling or in the wall all the time and can beacon out their location. But they have a hard time figuring out what their location is, especially doing that in an automated way. And some of the spur for this actually has also been regulatory. Through our efforts to coordinate spectrum in 6 gigahertz, we've needed to find out where we're going to be transmitting from so we can make sure we're not going to interfere. That process of finding out where we're going to transmit from has had consumer and commercial byproducts that are really beneficial. So that was more than 30 seconds, but
Yeah. No, but you're describing very complex, sophisticated networks. This isn't your grandmother's Wi-Fi anymore. This is networks doing very complicated calculations in the background in a very sophisticated way that obviously enterprises are willing to pay for because it gives them data that they don't have that they want. So that's really
not only not our grandmother's Wi-Fi, but not even my own Wi-Fi when I'm at home. We have 2 routers in this house, and that does just fine with all the devices and everything we want to do. But it's just me and my wife and a dog. So it's very different in a large public venue or in a manufacturing facility where client devices are all doing different things, not necessarily compatible. They're very dense networks, maybe hundreds of nodes at a campus like Monisha's, thousands probably. Huge amounts of data going through, and all of that needs to be coordinated as those devices move through space. That's not anyone's home network.
Wow, that's a lot to think about. Let me throw a question to Monisha. So radio spectrum is used for a variety of things, right? So from operating a garage door to streaming video to your TV set, making your mobile phone work when you're out and about. And while consumers don't think about it that much, what enables all of this diversity in use cases is a range of business models, right? So licensed service providers purchase exclusive use spectrum at auction or through mergers and acquisition, and they sell subscription services to us. No one else can use their spectrum. But in contrast, device manufacturers like HPE make things like access points and laptops and TVs, And they just simply insert radio modules into these consumer devices using unlicensed spectrum that's available for everyone to use for free. Why is it important to have these different business models? And are there spectrum bands that work best for each?
Thanks, Mary, for that. I'm actually teaching a course on wireless networks this semester. And one of the things I like to explain to my students is the different use cases of Wi Fi and cellular. These are both, I think, indispensable to the way we stay connected. They each have their place. But the story I actually told them just yesterday was I've been doing 802 standardization for many years. And when I started out, this was in the early 90s, everybody would have their presentations printed out, and there'd be a stack of paper this high on the desks at the back and everybody picked up their copy to follow through as the meeting went on. And as soon as we had, Wi-Fi, and back then it was just 2.4 gigahertz Wi-Fi, the way we operated changed. Everybody now could download the documents on their laptop. There was no need for paper anymore. So it just changed the way we operated. And that was something that you could only have done with something like Wi-Fi. That's not a use case that could be done by cellular. So having different kinds of spectrum bands that allow you to do these things is very important. For me, the biggest contribution of having the unlicensed bands, which is not just Wi-Fi, you have Bluetooth, you have Zigbee, you have Bluetooth low energy. You can even actually in 6 gigahertz do things like fixed wireless if you wanted to. It just allows you to be a lot more innovative in the kind of systems you can dream up. So without having access to spectrum that you don't need to pay a license fee for or buy at auction just allows the average innovator and entrepreneur to build products. And the explosion of products that we've seen in the unlicensed bands, which had their origin really as junk bands, that nobody thought you could use these frequencies for anything useful, have morphed into this indispensable part of our existence. Having said that, I think where we are at a point now where going back to the location problem that you were asking Stuart about is our dependence on wireless for being connected is also creating new challenges and opportunities. So just yesterday, they took my plugged-in phone off my desk. We are not going to have phones anymore that are plugged into the Ethernet. It's all going to be over, the wireless network. The new dorms that are going up on campus barely have any Ethernet jacks in the room. So the move is towards really going to a connected infrastructure which relies on wireless first. So yes, you have fiber coming into a dorm, but then it is really driven by access points. So the pressure on making these systems reliable, location services are extremely important to enable E911, whether it's through Wi-Fi calling or whether it's through private networks inside. And I think it's really crucial for us as a community to keep these challenges in mind as we're thinking about what to do with spectrum next. So right now on campus, we've deployed an experimental CBRS network indoors, and part of it is going to, and I know you're going to be going into neutral host later on, part of it is going to be deployed as a neutral host because the cellular coverage indoors is really bad. So most of the time, you can barely make a phone call. And Wi-Fi calling is an option, is a solution. When I'm in my office, I'm on my Wi-Fi network, I can do that. But there are many spaces where you can't. And so the whole idea of having different kind of spectrum bands to deploy private networks or alternative means of staying connected are increasingly important.
Well, I'm fascinated that the wires at Notre Dame are disappearing in favor of a wireless overlay. I can think of many applications for that, such as places in older, low-income, multi-dwelling units where it's just hard to wire some of these buildings to get connectivity into living units. It is fascinating to me that that Notre Dame is taking that step. And you did talk about the reliability issue, so I'm going to skip ahead. Stuart, reliability is emerging as a huge issue for enterprise more generally than just in this one education example.
Mhm.
Why? We're hearing about it with Wi-Fi 7. We're hearing about it for the next standard that's on the drawing boards. The importance of enhancing reliability in Wi-Fi. It's true for CBRS. Why are we hearing about it now? What is this moment we're in where all of this notion of the importance of wireless reliability is coming to the fore?
Let me try to answer that in a way that circles back to something that Monisha was saying earlier that I want to comment on as well. But yes, you are right. When Wi-Fi was first introduced, and I think actually, honestly, most deployments today, it's considered a best effort technology where it connects you to the outside world and you get huge amounts of bandwidth, but there's no real effort to schedule or control that access in a way that is deterministic or predictable, which is a clear objective for the cellular networks. And so I think historically and traditionally, we've seen a kind of trade-off between efficient, inexpensive, high bandwidth, scarce resources, and more and more, especially as we take the wires away, there are use cases emerging that push the capabilities of Wi-Fi, whether that's because we need something to happen on schedule or because we need to prioritize, say, the back of house traffic, the business that's going on in a university or a casino or a stadium versus all the crowds and the people who we also want to serve with that same resource. Do we share the same resource or do we split that somehow between a cellular and a Wi-Fi? And this is the point where I want to come back to Monisha's point. I think that there is, I do this a lot, I know, and I'm not saying you did, but I think that there's a tendency to conflate the technology and the spectrum to say, look, there's cellular technology that's operating outside in exclusively licensed spectrum, and there is Wi-Fi that is operating in shared spectrum or an unlicensed spectrum. And one of the things that's really happened is we started to look at ways that we can get higher capacity in cellular networks and get more reliability in Wi-Fi networks. It's all that's blurring. So the distinction between the two technologies, now I guess probably 3 or 4 technologies like that, and the spectrum that they use has started to blur. So we had a movement, I don't know, 7 or 8 years ago, driven by one of my former employers, Qualcomm, to move cellular into unlicensed spectrum, put it in the hands of people who were not necessarily mobile network operators. Expanding capacity. There's been a move to have private cellular networks, private 5G networks that are operating in, if not unlicensed spectrum, at least a shared spectrum resource. And so we've created these models for trying to figure out how we're going to share this spectrum. And part of that is around cellular technology like private 5G, but part of it is around Wi-Fi sharing spectrum with existing incumbents in order to get more space. So reliability and sharing are actually really important counterparts to each other. And even though, I'm just going to say one more point on this, but even though private 5G, which is a big part of our reliability story, has been around since 5G discussions started, until CBRS was opened and similar spectrum in other countries, you would have had to rely upon a mobile network operator to get it. And frankly, most of our customers don't have that kind of relationship with a mobile network operator. They don't. It's easy to be a subscriber of a mobile network operator. It's kind of hard to be a corporate customer of a mobile network operator who's taking services and deploying a network. Being able to.
And why is that? Why is that why do we need private 5G? What is it about customer operations and needs and careabouts that make it impossible, or make it, I don't want to say impossible, but make it more difficult to be
yeah, and I
by?
really don't want to say it's impossible, because
Yeah.
a lot of our customers are doing more or less the same things with Wi-Fi, and until recently, until it became possible, that's what we were encouraging them to do. But we've got customers who have very large geographic areas that they're trying to cover with Wi-Fi, like the Notre Dame campus, and it is more efficient to be able to operate at higher power with a technology that was meant to be a kind of umbrella than to have lots of nodes all around outside. We've got client devices that are moving a lot faster than pedestrians now. So Wi-Fi was designed for walking around an office space. We've got Wi-Fi on tablets, on forklifts, and on robotic devices that are picking up things from warehouses and putting them in loading docks. They're moving, I don't know, 3-4 times faster than Wi-Fi was designed to handle a handover, and we don't want to lose contact with them. We've got a lot of, as I alluded to before, privately managed public spaces where Wi-Fi is a service for the guests and the visitors, like in hospitality or in venues, public venues, universities. But Wi-Fi is also serving security and ticketing and administration and all sorts of other things that are on a different priority level. The way that Wi-Fi works is basically a paper, scissors, rock scheme for the spectrum, and everyone is an equal player in that, and it's very fair. But some of those networks would rather be a little bit less fair to some users than to others in order to achieve objectives. So cellular is a technology that allows us to schedule, but it also, importantly, can operate in a separate physical space. So it's not contending for the same air interface resources as Wi-Fi. We need them both. We need, everyone gets access, and it's a lot of bandwidth and very easily available. But we also have some needs that are on a different need a different kind of prioritization.
So what appeals to the enterprise customers? Is it because they have these very bespoke needs for how they're going to use wireless? Is it because they can do it themselves? Is it because the price points are different, that they wouldn't? What is it about that they wouldn't go to a mobile operator and say, just give me a service that does this?
Well, I think that ideally what they would most like to do is just raise their hand and say, give me a service that offers this, and have someone come and give it to them, exchange for money, without a lot of hassle. I don't think that they're very concerned about what technology solves the problem. They got a problem and they want the problem to be solved. Historically, it would have been a little bit hard for them to persuade an operator to engage, because it's awkward to reuse your public spectrum that you've paid a lot of money for a very specific application at one particular place. That's not easy to do. Most of these venues, they're already operating a fixed network. They're already operating a wireless network, but they've got some problems that they haven't quite been able to solve, and they would like to augment those. And the first place they go are the people who have been providing them with networks all along, because they're hopeful that they will be able to provide those in a way that are familiar in how they manage things already, use the same vocabulary that they have today, hopefully reuse a lot of equipment and expertise. And that's not historically been the story that they would give if they went to a mobile network operator or just tried to use a public network.
Monisha, I want to come back to you, because we've said the word CBRS, Citizens Broadband Radio Service, several times here. Can you tell us what that is? And also, from a consumer's perspective, what are the benefits of having CBRS as a radio capability? Why is it important for the United States to have that?
Thanks, Mary, for that question. So CBRS goes back to I think around 2012, or maybe even before that, when the federal government and the FCC looked at the band of spectrum, which was between 3.55 to 3.7 gigahertz, band. Now, this is a band of frequencies that at that time was solely dedicated to a very specific kind of radars which were deployed on ships. Now, clearly, radars deployed on ships are being used in oceans, and so they needed access to that spectrum just along the coastline of the US. But according to the allocation methodologies being used back then, it was an exclusive allocation, which means that band could not be used anywhere in the country. And even along the coastlines, the Navy radars weren't there everywhere and using it constantly. So the idea came about that perhaps this band could be shared in a way that these Navy radars, who clearly their mission is extremely important, needs to be protected when they need the band, could be protected, but at the same time, a mechanism could be developed which would allow the band to be used elsewhere in the country under a shared situation. So, it was dubbed the innovation band when they started creating the rules for it. And it took a while, but I think what we have now today is a band where the incumbents, the tier one incumbents as they're called, the Navy radars, are still operating. They are protected by a system of sensors and databases that can detect the presence of a Navy radar when it shows up at a certain location. And then, we have to be sensitive to security requirements. We don't necessarily want to broadcast the location of these Navy radars and what they're doing. So instead of doing that, the information goes to a secure database. And all the database does is tell any devices that are using that particular frequencies that they have to get off and find another band. Now, the way the band is used by consumers is also got two tiers. So you have the tier 2 users. These are called priority access licensees. These are folks that actually bought licenses in an auction that was held in 2020. So just like exclusively licensed spectrum can be auctioned, shared spectrum can be auctioned as well. And the beauty of this method in CBRS was you didn't have to buy a nationwide license. So you could buy a license and pay just about the amount of money you needed for your operation. So, for example, you had people like John Deere who run tractors, and they are not a mobile network operator, but they need spectrum to operate a lot of the precision agriculture applications out in acres of farmland where there is no public network. So they could afford to buy spectrum at reasonable prices because they were just trying to cover small regions. You had other entities like, I think, some oil refineries and others who bought spectrum because they had a bespoke need to provide services. But in addition to this, you also had what's called general authorized access. This was the tier 3 users who didn't have to pay for the spectrum, who could use the spectrum if it wasn't being used by tier 1 and tier 2. So if you're in a region like in South Bend, we're in the middle of the country, there are no radars, Navy radars anywhere in sight, and there are PAL users, but if none of them are using the band, there's no reason that a third tier of user cannot use the band, very much like unlicensed access in Wi-Fi, except you still have to go through the database, get authorized to use a certain band. And then once you've done that, you can use higher power than Wi-Fi. You can use cellular technologies if you wanted to. And you can deploy a network according to your needs. So an example I can give over here quickly is the South Bend School District. During COVID, the city realized that there were a number of low-income households that didn't have access to broadband during that shutdown period. And so the school district decided to use a couple of their schools, a middle school and a high school, and a couple of towers, plus fiber that was available to them in these locations to deploy CBRS network that covered local residents who couldn't afford to pay for broadband. So this was something that was under the control of a local community. They didn't have to pay for the spectrum. They had to pay for the equipment and the deployment and management of the network. But that was something, the technology today is not quite plug and play, but it's getting to the point where, say, an IT department of a city can actually set up and deploy such a network. So this kind of use is completely new. It wouldn't be possible with the regime that we had before. And actually, where I sit today, and we've done a lot of work on neutral hosts as well, I think just having 150 megahertz, which is what we have today, of shared spectrum is too little. Because the use cases that are developing, so the school district connectivity is one, indoor connectivity using neutral hosts is another one, oil refineries, precision agriculture, John Deere and others using it, warehouses, like Stuart mentioned, when you have really large spaces to cover, you can do it sometimes better with fewer access points in CBRS rather than Wi-Fi. Not to say that Wi-Fi goes away. Wi-Fi is always going to fill a need for consumer-facing applications. Hospitals is one application in particular, Mary, you'd asked about is what is it that enterprises need and why do they go to private networks? One of the papers we wrote recently is about a hospital in the Stanford Medical Center, actually, where they realized that they needed a separate network to run their operations off. So doctors today are always wirelessly connected. They all have their iPads. Some of them could be on their personal networks. What they found is that the cellular network coverage in these hospitals is so bad that they really it was affecting their operation. In addition, patients and their families, when they go to a hospital and their cell phones don't work, it's not a good user experience for them. And they don't necessarily want to get onto the hospital Wi-Fi network just to make a call. So they deployed a private neutral host network over CBRS in this hospital, which is like multi-purpose. It's a private network that they can run their operations on. It serves as a neutral host for cellular operators. So if you're, say, an AT&T or a Verizon a customer and you walk into this building, your phone automatically detects that you can hand off to the indoor network and get much better performance. We've quantified some of the improvements you get. They are 10 to 20 times better throughput over the private network rather than trying to connect to a macro. And so, this deployment is not only shared spectrum, it's shared infrastructure. So you have one infrastructure that's deployed inside the building, which can serve multiple purposes. And it's really giving rise to a lot of innovative applications as people realize what you can do once you have, as Stuart mentioned, the quality of service that you can get over a cellular technology over a private network. And it's absolutely essential to separate the technology from the frequency it operates in. So taking a shared band, deploying a cellular technology in there is really providing benefits to customers and enterprises as well as end users.
Yeah, and I would just add for people who don't realize this, the physics of trying to get a cellular signal from an outdoor tower into a modern building is only getting worse over time because we're making our buildings more energy efficient. And as we do, that blocks cellular signals more and more. So that really is a problem when you walk into a modern building these days, that the cell signal just drops off to nothing. And you need another network such as CBRS or Wi-Fi in order to be able to stay connected.
And just to add on to that, Mary, it's actually getting worse with 5G because 5G, the newer cellular frequencies are going higher up in frequency. And this loss that you mentioned is inversely proportional to the frequency. So the higher you go, the more of a loss you get when you're trying to penetrate buildings. So it's not going to get better. It's actually going to get worse. So the technology itself cannot overcome the physics of propagation, which limits.
And there's a third dimension to that problem, of course, which is that the mobile network operators, in order to densify the networks and to get more capacity, have put the cell towers closer together. And when they're closer together, they're operating at a lower power level. And when they're operating at a lower power level, they have even more trouble getting through the building walls. Mary, you asked before whether the things that were driving people to look at things like private cellular were bespoke or niche applications, and many of them are. But this problem of indoor cellular coverage affects, I would say, probably 90% of the businesses that we deal with. Even large corporations, they have smaller regional offices or clinics or hospitals that it just doesn't make sense to create a whole indoor cellular infrastructure to support each of the individual operators, but the outdoor cellular coverage isn't getting in. And they don't have a good solution for this problem today unless it's a neutral host solution. And they're prepared to invest in that, but there are a lot of constraints. I don't think they would do it at all if they had to rely upon licensed spectrum, because the negotiation with the public network is too difficult. And there is, as Monisha pointed out, these resources are scarce. 150 megahertz of spectrum makes you have to think twice when it's a tenth, less than a tenth of the spectrum that the Wi-Fi network indoors has. So you would have a trade-off between capacity and coverage or convenience. You have to be careful about what you're going to use that 150 megahertz for, because it's not an infinite resource.
Well, I want to bring this conversation to a close. This has been a fascinating look at all of the changes that are happening in the wireless space, with indoor networking, with location, with new ways of sharing spectrum, and all kinds of technology developments that are happening faster than I can keep up with them, to be perfectly honest. Which, again, shows me that we're going to need unlicensed spectrum and shared spectrum like CBRS, as well as exclusive use spectrum going forward. We really can't do without it. And we probably need more shared spectrum and more unlicensed spectrum, given how heavy our indoor usage is. So before we conclude, I would like to ask each of you if you have any concluding thoughts you would leave policymakers with about what's happening in wireless and what's important now.
I would just say, I think the most significant development in my recent memory, past 5 or 10 years, and you and I have been on that path together, Mary, is the development of models for sharing spectrum. So that you mentioned at the beginning also that there are some changes afoot to try to identify spectrum to license, and I think that's largely revenue driven. Those don't need to be mutually exclusive uses of this scarce resource. I think we've proven with CBRS and with the automatic frequency coordination of 6 gigahertz that effective models exist to allow exclusive uses in some contexts, coupled with general access for others, in a way that all of the different users get to live together and accomplish what they wanted. And I think that's a tremendous way of approaching a scarce resource.
Monisha.
Yeah, I agree. I think we have to do sharing. I think the beauty of sharing is that you don't have to kick anybody out of a band, which requires time, which requires money. You don't get to exclusively license spectrum without doing that, because all this current spectrum is being used. And if we are more careful about how we share, many of the existing incumbents in the federal bands are outdoor users. And as we've discussed, a lot of the users are increasing indoors. And as we've seen with 6 gigahertz and with CBRS, you can actually layer on indoor users in the same band that outdoor users are being used without displacing anyone at all. And the more we begin to realize that we can do this, in my mind, I think about it as real estate in New York versus real estate in South Bend. People have single family homes here with big yards because there is space. In New York, you go up, right? Because you're limited in space. So I think about shared spectrum the same way. We have to figure out ways to layer on more users in the same frequency that we have, rather than spread users out in frequency bands which are not going to be available anymore.
Well, that's a great sum up thought to end this panel with, because I think it does represent the future challenges that we will all have in the wireless world in order to get more out of wireless and do more for our communities going forward. So I want to thank you both for joining me today. And this will conclude the panel. Thank you.
Thank you.